Welcome back, guys. In this video, we're gonna use the derived equations from the previous video to find what are the equations governing the uniform rectilinear motion and the uniformly accelerated rectilinear motion. First of all, what about a uniform rectilinear motion? A uniform rectilinear motion means that the velocity is what? The velocity is constant, all right? So if the velocity is constant, guys, then of course the acceleration will be equal to 0. What about the position, s? How to find s? What is the equation of s in terms of v and in terms of the time t? Now the second type is uniformly accelerated rectilinear motion. What does this mean? Uniformly accelerated means that a is equal to a certain constant. If a is equal to a certain constant, what will be the equation of v? And what will be the equation of s in terms of this a and in terms of v and the time t? Let's do it. So I'm going to start first by the first type, which is uniformly rectilinear motion. And in this case, as we said, v will be equal to constant. So if I do the derivative of v with respect to time, then a will be equal to 0 because a is equal to dv over dt. Now, how can I find the position? Alright, guys, I know that v is constant and the equation of v is given. V is equal to vc, which is, it is a constant value. Alright, so how can I find s? I know that this v, I know that v is equal to ds over dt, alright? And I know that this v is always constant and it is equal to vc. So vc is equal to ds over dt. I need to find s, alright? So if I want to find s, then ds will be equal to what? To vc over dt, alright? So in order to find s, I have to do the integration on both sides of this equation. And don't forget, guys, in order to get rid of the constant, I should put boundaries on this integration. So I'm gonna put both integration with boundaries, alright? The boundaries here will be on in terms of time t, because this is the integration with respect to time, while the boundaries here will be in terms of s because it is the integration with respect to s. Now guys, I can start here from t0 till t, till any time t, or I can say that this t0 is 0, it is the initial time. So from 0 till t, because guys, I know that t0 is equal to 0. I cannot say that this ds is going from 0 till s, because I don't know if at time 0, at time t is equal to 0, s is equal to 0. S is equal, in fact, to any s0 at this time 0, right? So this s0 corresponds to the initial time, it is the initial position, and this will be s that corresponds to this time t, right? So this means, guys, that s minus s0 is equal to the integration of vc dt, and since vc is constant, then this could be removed from integration, and then vc what? T minus 0, which means vct. From here comes this equation. So s will be equal to vct plus s0. What is s0, guys? What is s0? S0 is not any constant. It is the displacement, or it is the position coordinate at t is equal to 0 at the initial time. Now, what about the uniformly accelerated motion? As we said, the uniformly accelerated motion means that a is equal to a constant, so that's why I'm gonna call this constant ac, and I know that the velocity is equal to the integration of ac dt, and the same goes here, guys. If I know that the initial time is 0, because I can start from t is equal to 0, this doesn't mean that v0 should be equal to 0. It could be, but it's not always, alright? So I should put here v0. v0 corresponds to the time, the initial time when t is equal to 0, and this is v. Then of course, guys, since ac is constant, right? So it is very similar to the uniform motion, except that here I'm dealing with v and ac instead of s and t. Then I can remove this ac from the integration, and then v will be equal to act plus v0, right? What is v0? Don't forget, it is the velocity, the initial velocity when t is equal to 0. Now, how can I find s? I know, guys, the equation of v with respect to time, and I know that v is equal to ds over dt. So I can replace this v with the equation of v with respect to time, and then I can do the integration. And don't forget, guys, since I have to start here from t is equal to 0, then here I have to start from s0 that corresponds to the time t is equal to 0. And then, guys, I'm gonna do this integration since AC is constant, and I have to do the integration of ACT. Then the integration of ACT will be AC, since it is constant, t squared over 2. And what about the integration of V0? Since V0 is constant, it is the initial velocity, then the integration will be equal to V0 t. Alright, so S minus S0 will be equal to ACT squared over 2 plus V0t, and then I can remove this from the left side and put it to the right side, so the equation of S will be equal to half ACT squared plus V0t plus S0. I'm sure, guys, you went over this equation in the projectile motion in physics, and then this will be equal to y, right? Now, another equation is the equation ADS is equal to VdV. This is the independent equation, and we have already derived this equation. This is the independent equation with respect to time. So, of course, since A is constant and it is AC, right? So I can find, in fact, V, alright, so V dV is equal to the integration, so I have to put both integrations here, and now here, guys, I cannot start from 0, right? I have to start from V0, this is not time, and then here I have to start from S0, this will be to V, and this will be to A. Now, what is the integration of this one? It is V squared over 2 between V0 and V, which means this term. Alright, now what is the integration of this one? Since AC is constant, so this is the case where AC is constant, this is uniformly accelerated motion, then I can remove this AC from the integration, and then this term will be AC S, sorry, this is S, alright, S minus S0, which is this one, and then, guys, I can say that V squared is equal to V0 squared plus 2ACS minus S0, and I'm sure also that you knew this equation also from the projectile motion, right? So this is the velocity as a function of position. Thank you.